Hey everybody, welcome back. I wanted to make another quick video, and I really wanted to talk about writing chemical formulas from a name and then writing names from formulas. I just kind of want to go through all the steps one more time just to give you something you can kind of fall back from when you're watching the videos. I almost said if you're watching the videos. I'm kind of hoping you guys are. But I want to start with writing a couple chemical formulas, and I think I'm going to do barium chloride. And I really shouldn't have said what that is, but there it is, BaCl2. And then I'm going to take Ba. Okay, so I have two compounds here. And I have a chemical formula, obviously, with both of these, but now I want to write a name. And if you remember, when we write a name for a chemical formula, especially if you're looking at this, you see two things in here. And the key is you always write the name of the first element regardless. So in this case, the first element's barium. Now the second element, if you remember, the second element's name is chlorine, but whenever it's the ending for a chemical formula, we always chop off the last three letters and write in IDE. So I'm going to write out barium chloride. And there we go. So barium, BaCl2 becomes barium chloride. All right, onto the compound down below. Now, is this the same thing as barium chloride? I mean, it's got chlorine in it, so it must be the same. Well, no. If you guys remember what we talked about in class, chemical formula is like a fingerprint for that compound. There is only one way you can write the formula for barium chloride in existence. There's only one way barium and chlorine can combine and be barium chloride. If there's another way, we have to name it something different. So this compound down below can't be barium chloride. Now, if you remember, the radical or the polyatomic ion that's inside here, ClO3, is actually the chlorate ion. So how am I going to name this? We got to do the same thing we did above. I start by simply saying the name of the first element, which happens to be barium. Now, people ask the question, we know that this radical is chlorate. Do I still have to follow the same rule and chop off the last three letters and put IDE? And the answer is no. Radicals have their own names already, and we don't have to do anything to them. So if I want to name this compound, I simply say the names of both things, barium and chlorate. So we end up with two compounds which have their own individual names. There's no other compound that can have the name barium chloride. There's no other compound that can have the name barium chlorate. Now I want to kind of skip gears a little bit. Okay, let's take a look at these three compounds. Now, these are three interesting compounds. I've got copper. If you remember, copper is the element Cu. Copper in each one of these. So the first letter, or the first word for each one of these compounds is going to be copper. So I'm going to go ahead and fill that in. All right, we're back. So the first name is copper for each one of them. Now, if you go back to the periodic table and find the element P, that's phosphorus. And when phosphorus gets put into a chemical equation, we automatically change the name to phosphide. So I'm going to go ahead and do that for this compound. Okay, so this compound is copper phosphide. Well, what's this compound? Well, it has copper and it kind of has phosphide. So what does that mean? Well, it actually kind of means that this compound is copper phosphate too. So I really need to copy this and paste it right here. And if this has copper and phosphorus, it also must be copper phosphide. So those three compounds are copper phosphide. And one of the questions I might ask you is, do you kind of have a problem with that? Because what I just got done saying on this slide is that both of these compounds are unique and they have their own unique name. So how do we end up with a situation like this where I have three completely different compounds but exactly the same name? And the reason is there's something else we have to do here. The first thing you should recognize is copper is a transition metal. Transition metals can have different charges. It can have a +1 copper, +2, +3. So there's got to be a way of writing this in this chemical formula so anyone can look at this name and say, oh, this name only applies to this formula. Okay, ready? And the way we need to do that is we actually need to go back to the chemical formula. We need to take a look at it to evaluate what are the charges of these two ions, but most importantly, what's the charge of copper in this formula? Okay, so all I did is copy this formula onto a new page. So, got to go back, we have to do a little bit of work, and we have to ask ourselves, all right, copper is an element that can actually change its charge, so I can't just automatically assume it has a charge of +1 or +2. So instead, I have to look at the element that doesn't change its charge. And if you remember on your periodic table, phosphorus falls into the group where things form a -3 charge. So I'm going to fill that in here. Phosphorus makes a -3. Now, sometimes you can put like a little divided line on each side of the chemical equation. Here's my negatives over here, and here's my positives over here. And some people go as far as to put another line here so they can actually add up the charge on each side. And so far, the only thing giving me a negative charge here is phosphorus. So phosphorus must donate the -3 charge. Well, remember, this is something which has to balance. So if I add these two things together, I need to get to 0. Well, the only way that can happen is if this entire side of the equation is a +3. Now, keep in mind, a lot of people see 3 and they see a 3 here for copper and they're like, oh, copper's a +3 charge. Well, is it a +3 charge? And the question you want to ask yourself is, how many coppers are here? And if you look at this subscript 3 refers to the fact that there's 3 coppers. So technically, this +3 charge is actually being split 3 ways. And the only way we can do that is if each copper atom in there gets a +1 charge. 3 +1 charges added together gets me a +3, which can only mean that this copper on its own is a +1 charge. Okay? So we're going to go back to the formulas we had a minute ago. If copper is a +1 charge, then the way we recognize this, the way we write it, is by adding in a parentheses, and we add a Roman numeral which reflects the charge of the metal ion. In this case, we use the Roman numeral 1. So just to recall, copper is the atom with a +1 charge, and we don't really care right now what the phosphorus is. So this formula, copper 1 phosphide, is unique to this formula. Okay? It's unambiguous. If I gave you copper 1 phosphide, okay, this can only mean this particular chemical formula. Okay, let's go on to the next one. All right, we're back. So all I did is copy this formula onto the next page. We're going to do exactly the same analysis here we did before. I'm going to put a dividing line here through. I'm going to add up these charges. And we know right now that phosphorus forms a -3 charge. But I have 2 -3 charges. So altogether, this has to add up to a -6. All right? 2 -3s gives you a -6. And we remember in the end, all of this has to add or sum up to 0. So how do I get this to happen? Well, the only way that can happen is a +6. So +6 minus 6 gets me 0. Now, just like over here, we had to ask, how is this +3 distributed? Now I've got a +6 that's distributed amongst 3 coppers. So how do you chop up a +6? You got to chop it up 3 ways. I have a +2, a +2, and a +2. 3 +2s get me a +6. So in this case, the copper ion has to be a +2 charge. And if I go back to my formula, now the Roman numeral and the parentheses that I add in here are going to be copper with a Roman numeral 2 phosphide. Copper Roman numeral 1 phosphide, completely different compound than copper Roman numeral 2. I can't talk. I can't talk at all. I don't know why I can't do that. Anyways, last compound. This one we should be kind of pretty good at. If you remember, phosphorus is a -3. The only other atom here is copper. So in this case, copper has to be the +3. So the way I'd represent that in this formula is like this. I've got a copper Roman numeral 3 phosphide. So this is how we write the names for chemical formulas only when the metal element that's in here is a transition metal. If you remember back to the first examples we did, I did not need to put a Roman numeral in between the barium and chloride because barium is not a transition metal. This is something that's tricky for people who are just getting used to doing this. So you may need to kind of look at your periodic table while you're solving these problems to kind of ask, All right, is my metal a transition metal or not? Do I need Roman numerals or not? Okay? Okay, I want to do a couple more examples so I can keep this video short. So before we took a formula and we got a name, now I want to take a name and get a formula. So what you might have to do with this is take a look at your periodic table, and you're going to have to find the element strontium. And if you're looking, this is on the left-hand side of the periodic table, and strontium is the element Sr, and strontium has a +2 charge. Now, you should know your radicals. And acetate is one of the 16 radicals that I've given you. And acetate is a -1 charge, but it's got a couple elements in it. It's got 2 carbons, it's got 3 hydrogens, and it's got 2 oxygens. And as a whole, if I put parentheses around it to represent the whole thing, the whole it has a -1 charge. So if you're doing the math, like we've done in the past, if you take a look at the two sides, I have a +2 and a -1. I know somehow that has to get to 0, and the only way that can happen is if I have an entire second acetate ion. So I'm just going to pause and draw that. All right, so there's a second acetate ion. A +2 will balance or neutralize with 2 -1s to get me 0. So now I have to write a chemical formula for this. And it brings up a point that a lot of people have questions about. Do I need to put parentheses in the formula or not? Well, let's take a look. Okay, we're back. Now, so regardless, the chemical formula that I write still has to have both of these things. It has to have strontium and acetate. And I put these a little bit far apart, and I'm not intending to do that. Let's see if I can kind of correct that. There we go. Move them a little bit closer. Okay, good. So, how do I represent the fact that my chemical formula needs 2 acetates? This is a case where I have to put a parentheses, because if I just put a 2 here, the outside observer is going to look at this and say, oh, this formula is SrC2H3O22, and that's not the case. If you look over here and count up all the oxygens that we have, there's 2 oxygens here for a total of 4 oxygens. Obviously 22 does not represent 4. So the way to do this correctly is just to put parentheses around it. Now the subscript 2 tells me I have 2 entire acetates, and this is the formula that is represented by the name strontium acetate. Okay? Look, this is a type of thing that requires a little bit of practice. You're going to have to take a look at some of the things that I gave you, and if you need any help, don't hesitate to take a look at the video or ask me in class or ask a friend, okay? Got to self-advocate. All right, great. See ya.